Let's start with the basic but important question. What exactly is temperature? Temperature is a measure of the average kinetic energy of particles, like atoms or molecules in a substance. In thermodynamics, it's measured on an absolute scale, most commonly Kelvin, where 0 reflects a complete stop in particle motion. Now, to put it simply, think of a group of kids jumping on trampolines. When it is cold, they are bouncing slowly, relaxed and calm. But when it's hot, they're jumping like crazy, faster and higher. It means that the faster particles move, the higher the temperature. That's what temperature really tells us, how fast the particles are moving. What is pressure? Pressure is the force gas molecules exert when they collide with the walls of their container. The more often and harder they hit the walls, the greater the pressure. Now imagine a bunch of energetic kids bouncing around in a room. If they bounce gently, the walls barely feel it. But if they crash into the walls full speed, the force adds up fast. So, pressure comes from billions of tiny impacts, each molecule pushing just a little, but together creating a powerful force. After knowing what is temperature and what is pressure, what is the relationship between temperature and pressure? Now, let's put those ideas together. In a closed space, like a party balloon, when it's cold, the air inside the balloon is chill. Molecules move slowly, they barely bump into the walls. That means gentle pressure and the balloon stays small. But when it's hot, like leaving the balloon in the sun, the molecules speed up. They hit the walls harder and more often. The balloon swells and might even pop. That's high pressure. So here's the takeaway. Higher temperature means higher pressure if the space doesn't expand. And lower temperature means lower pressure. But how do we actually measure pressure and temperature in a system? That's where the BMP180 sensor comes in. BMP180 is a digital pressure and temperature sensor. It is compact, precise, and super useful. It is perfect for detecting air pressure, temperature, and even altitude. And because it is so efficient, it is used in devices like smartphones, GPS systems, and outdoor equipments. The BMP180 connects easily to a microcontroller through I2C or SPI, making it ideal for your electronics and data gathering projects. Now let's look at the BMP280. The BMP280 is a compact, low-power barometric pressure sensor designed for mobile devices like smartphones, GPS units, and smartwatches. Built on Bosch's trusted piezo-resistive technology, it offers high accuracy, long-term stability, and strong resistance to electrical noise. What makes it special is its flexibility. You can adjust its settings to balance power use, resolution, and filtering, with easy default configurations for quick integration into any project. After knowing what is BMP180 and BMP280, This is the application of the two components. For BMP180, it used for indoor navigation, GPS enhancement for date reckoning, slope detection, sport devices, for example altitude profile, weather forecast, and vertical velocity indication, while BMP280 used for enhancement of GPS navigation, indoor navigation, outdoor navigation, leisure and sports applications, weather forecast, and vertical velocity indication. While in Indonesian Agency for Meteorological, Climatological and Geophysics, as known as BMKG, the BMP180 and 280 application is for the first one, air pressure monitoring. BMKG uses air pressure data for forecasting and extreme weather detection. They can serve as portable sensors in mini weather station or remote monitoring tools. And second, altitude measurement. Because air pressure drops with altitude, BMP180 and 280 can be used to measure station elevation, track sensor height during fieldwork, and monitor vertical air movement. Third one, calibration and validation of low-cost instruments. They are useful in educational and research projects by STMKG students, BMKG labs, and universities for developing low-cost weather monitoring tools. The fourth, microclimate monitoring systems. It can be applied in sensitive regions like mountainous areas or agricultural zones, and microclimate studies, example daily air pressure changes in valleys. As you can see here, these are the pictures of pin configurations of each BMP180 and BMP280. What we shows here is the diagram block components of each BMP180 and BMP280. And how does BMP180 sensor works? Here's the picture of temperature and pressure measurement process on BMP180 sensor. And this is how BMP280 works. This slide compares two pressure and temperature sensors, the BMP180 and the latest BMP280. While the BMP280 is more advanced, it's smaller in size and consumes less power, just 2.7 microamps compared to 12 microamps for the BMP180. It also offers better resolution and accuracy for both pressure and temperature measurements. Unlike the BMP180, the BMP280 supports both I2C and SPI interfaces, has built-in filtering options, and allows flexible oversampling up to 16 times. Overall, the BMP280 is a more efficient and reliable sensor. It is ideal for modern applications like Internet of Things devices, wearables, and smart systems.